All right, we're going to do section 2 today in chapter 3. And well, in section 1, we talked about parabolas. We talked about easy ways you can graph parabolas, how they move around. And it was strictly parabolas in section 1. Today, we're going to look at all the different kinds of graphs, cubics, square roots, absolute values, and talk more about those and how you can move those around. Do vertical shifts, horizontal shifts, and then eventually get everything combined. We're going to go through the first part relatively quickly because we looked at that in chapter 2. And then we're going to talk about using zeros to sketch graphs. Now, we're going to run into a little bit of a conflict. There's some folks here cleaning the carpets. So if it gets too noisy, I may have to stop and come back at another time. But we'll get started and see how it goes. Okay, just to get us started here, when you have a function, the 5 is called the leading coefficient. Okay, it's the number in front of the term with the highest power. Now, we already know that the highest power here is 4. The highest power is called the degree. Okay, so the number that's in front of the degree term is called the leading coefficient, okay? The 3 is called the constant term way at the end, all right? Like for down here, the negative 4/5, which would be the slope of this line, the negative 4/5 is the leading coefficient. This is the polynomial of degree 1, and the 3 is the constant term. Over here in this parabola, if you can see it, y equals x squared. The leading coefficient, the number in front, is a positive 1, and the degree is 2. And remember, with parabolas, the leading coefficient being a positive means that it opens up. If it's a fraction, you know it's going to be much wider. And if it's a whole number, it's going to be much more narrow. Okay? Quickie review there. Now, let's start over here at the right-hand side. If you have y equals x cubed, if you plot points and sketch it, 1 goes to 1, 2 goes to 8, negative 1 goes to negative 1, negative 2 goes to negative 8, you're going to get a graph like that. Remembering from chapter 2, this is indeed a function. It passes the vertical line test. This is indeed a one-to-one function, and you can find the inverse of it because it passes the horizontal line test. Okay? The interesting thing about cubics, when you have an odd power, and look over here, I've done a whole bunch of odd ones. The green one right here, the green one is x cubed. Then I have an x to the 5th and an x to the 7th. Okay, the brown one and the black ones. If you have any odd powers, they will always look like this. Okay, always. And I think we mentioned that before in here. The bigger the power, the more quickly it goes up. Okay, it goes up, it becomes more narrow. Same thing with an even power. When it's x squared, you know it's a parabola, like your green one here. All right? Then when you go to the brown one and the black one, x to the 4th and x to the 6th, they are still odd, even powers, but they start to go up much more quickly, okay? Much more quickly, and to be completely honest, these should be going up a little bit faster than what they are. All right, so odd powers are always one-to-one. Even powers are still functions, but they're not one-to-one because they fail the horizontal line test. Now, let's talk about, once again, what you can do with x cubed. X cubed is this blue one right here. Put a 2 in front of it. It goes up much more sharply, according to as the gold shows. If you put a 1/2 in front of it, 1/2 makes it wider, as this dark blue shows. And if you put a negative sign in front of it, it simply flips it up and down. Okay, when you put the negative sign in front of the whole thing, if you only put the negative sign on the x, it flips it left and right. We'll talk more about that in a second. So here is the blue one with a negative sign in front. This flipped down, this blue one flipped up. But the kind of cool thing, and I think we did this back in chapter 2, if you put the negative sign only on the x, if it's negative x, parentheses, quantity cubed, the cubic of a negative is still a negative. So if you put the negative sign only on the x, it's going to flip it left and right. And when you flip this blue one left and right, don't you get the green one anyway? Isn't that kind of neat? Okay, pretty cool stuff. A little bit more on parabolas. We talked about this in 3.1, our last time together. If you have your basic parabola, y equals x squared is right here. If you have a parabola, x plus 5 squared minus 3, the plus 5 means you bring it back 5 to the left. The minus 3 takes it down. And then you have this red parabola here. Okay? And remember how you get intercepts. If you want to find the x-intercepts, you set the whole function equal to 0. And in this particular problem, you'd have to use the quadratic formula, and you can see they got some ugly decimals there. Okay? If you want to find out where it hits the y-axis, you simply set the x value equal to 0 and work it out. Okay? And you get like 22 or something way up high. Okay? That was a bit of ancient history. We did that the last time we were together. Now, the really remarkable thing, and we talked about this a little bit back in chapter 2. If the blue one is the absolute value of x, if you put a negative sign in front of it, it simply flips it down, okay? The opposite of the absolute value, and you get the red one. And here is another absolute value that you should know. There's actually 4 things going on here. The minus 1 moves it 1 to the right. The plus 3 moves it up 3. The minus sign flips it upside down. And because it's a 2, it makes it go down much more sharply. And that's how you get that particular absolute value graph. All right? And there it's doing that again. All right. So let's talk about end behavior. Now, what I just showed you, an odd degree, like an x cubed, an x fifth, x to the 7th, you know an odd power, x to the odd, will always look like this. If the leading coefficient is positive, if the x term is positive, the graph is down on the left and it's up on the right. Down on the left, up on the right. If the odd degree has a leading coefficient that's negative, it's going to flip that whole baby upside down. It's going to flip it upside down, and it's going to be up on the left and down on the right. Up and down. Yeah? Even degrees. Even degrees, we talked about those. Even degrees are like parabolas. X squared is x to the 4th. If your leading coefficient, when you have an x to an even power, if this coefficient is positive, you know it's going to open up. And depending upon how high the even number is, it gets more narrow. If the even degree has a negative sign here, it's going to be opening down. Okay? Personally, I think it's things we've talked about before, but I just wanted to go over that. All right, let's get into some problems. This is very much like we did last time. All right, x squared plus x minus 6. If you want to grab it, you can make an XY table. I showed you how to do it, putting it into standard form. We're going to complete the square right here. If you complete the square, you cut 1 in half, you get a half. Now you got to check your work, okay? Checking your work, you write this down twice. X times x is x squared. A half x and a half x makes a whole x. A half times a half is a quarter, okay? There is no positive quarter up there. I have to get rid of a positive quarter, so I'm going to subtract a quarter. So I have x plus a half squared minus 6 1/4. Quick sketch. I know I'm going to be going to the left a half and then down 6 1/4. So I'm way down here. And because the leading coefficient is positive, and it's just normal shape, there's no whole number or fraction, it's going to open up and come up through like this. How about the intercepts? Says find the zeros. Okay, the zeros are when you set it equal to 0. This one I think will factor. So I could factor it into factors of 6, subtract, give me 1, 3, and 2. Put this with the bigger one, plus, minus. So I get -3 and 2. So it's going to hit at -3, and it's going to hit at 2. Okay, here's where it's turning around. So it's coming up through here like this, and up through here like that. Okay? That is doing it with standard form, and I found the zeros. Now, the beauty about this is, if you don't really like standard form, completing the square, you can really find, oftentimes, in most cases, find the zeros, and you can sketch it. For instance, finding the zeros, I knew it was 2 and -3, right? I knew it opened up positive, okay? So basically, you can just draw the parabola. How could you find this point? Well, don't you know that this point is going to be halfway between those two because of the symmetry in a parabola? So you know it's got to be at -1/2. The middle of 5 is 2.5 down, or 2.5 up is right there, or the average of -3 and 2 is -1/2. And you could put -1/2 into your function to get the -6 1/4. So you could have graphed it just using zeros instead of completing the square. So let's talk more about just doing it with zeros. How about graphing that just using zeros? Okay, so let's talk about it. Now, look what we know. Using zeros, we set the whole function equal to 0. You're going to get x equals -2, x equals 1, or x equals 3, right? So I'm going to have a 0 at -2, at 1, and at 3, correct? Now, if you were to multiply this out, wouldn't it be an x cubed? X times x times x? It would be an x cubed. And what's the end behavior of an odd degree with a leading coefficient positive x cubed? It's going to be down on the left, up on the right. So I know this thing has got to go down here, and it's got to go up there. Okay? Well, so what I can do, I can start drawing. It's going to come up through like this. Now, what happens? Does it go up there, or does it come down here? Well, let's put a point in. If you put 0 into this equation, here's 0. Putting it in, I get 2 times -1 times -3. That's +6. So I know at 0, it's way up here at 6. So I know it's going to do this. Now, when I get to here, does it bounce up or does it come down here? Well, put 2 in. Put 2 in makes 4, 1, and -1. That negative is going to make this whole answer negative. So at 2, I know it's down here in the negative, so it's got to come down here, and then it goes back up. This is, in essence, what Chapter 3 is all about. Can you take a very ugly-looking equation, and can you quickly sketch a graph? Okay? That is where we're headed. All right? Let's do the next one. How about graphing f of x equals x cubed minus 2x squared minus 3x. Now, I'll level with you, okay? On your homework today, every problem that I give you, these big, horrible, ugly equations, okay, they will always factor. They will always factor today. I won't guarantee that for the next time we're together. They will always factor, all right? So let's get started here. Rules of factoring. First rule, take out what's common, x. X squared minus 2x minus 3. Will this factor, or do I have to use a quadratic formula? Well, let's try it. Can you find factors of 3 that subtract to give you 2? Sure. You could use 3 and 1. To get 1 times 3 to be a negative, I know 1 is positive and 1 is negative, so put this sign with the bigger one in the outers are bigger than the inners. So I'm going to put negative here, positive here. Using zeros, set it equal to 0, set each part equal to 0, and you get 0, negative 1, and 3. Yes? Sketch. Zeros. 0, negative 1, 3. Okay? It's a cubic that's a positive cubic. Positive cubic, down on the left, up on the right. So I know it comes up like this, and it continues to go up like that. Now, you might guess and say, well, I bet it does the same thing as the last one. I'll bet it goes up here and down there. And it might. You can try it if you put a half, negative a half in here. Negative a half would make that negative, would make that negative, would make that positive. And 2 negatives times a positive makes a positive, so I know it does go up. You could put 1 in here, positive, positive, negative. That makes 1 a negative. It's got to be down. And it is like that. Okay? Try the next one. G of x. Okay, let's do the next one. Is g of x is negative 2x to the 4th minus x cubed plus 3x squared. And we're going to try to find the zeros so we can sketch it. I'm going to take out a negative out of everything and an x squared. Okay, so I'll pull out a negative and an x squared. And what do I have left? I have a 2x squared. I have a positive x. And I have a minus 3. Yes? Okay, I think I got that right. Is equal to 0. All right, so I have negative x squared. Now, will this factor? Let's check it. This is a tough one because there's a number here. So I have 2 and 1, 3 and 1. I must find a combination that subtracts to give me 1. If you pair the 3 with the 1 is 3, the 2 with the 1 is 2, they will subtract to give you 1. So I'll put the 1 here and the 3 that I circled on the outers. The other remaining factors, the 1 and the 2, flip on the inners, x, x, to get a negative 3, 1 is positive, 1's negative, so go by this sign. The positive sign goes with the bigger one, and the outers are bigger, so plus, minus. Think I've got that right? Okay? Now, when you set all 3 of these equal to 0, if x squared is 0, I get 0. Let me write that correctly. So if x squared equals 0, I get 0. If this equals 0, I get 1. If this equals 0, I think it's negative 1.5. Okay? Sketch it. Sketch. It hits at 0. It hits at 1. It hits at negative 1.5. Okay? Now, what about end behavior? This is an even power, even degree, with the leading coefficient negative. Even degree with leading coefficient negative, it's down on both sides. So it's got to come down this way. So I know it's going to come up like this. Now, what's it do? Does it go above here or does it come back down here? Well, try putting negative 1. Try putting negative 1 into here. Whatever, this is always going to be negative. Negative here makes a positive. Negative here makes a positive. So a negative times 2 positives is a negative. And I wonder, did I do that right? Let me try that again. If I put negative 1 in, negative 1 in here, squared is a positive times a negative is negative. So this is negative. Negative 1 here is negative. And this is positive. 2 negatives, these are both negative. 2 negatives make a positive times a positive. Yeah, this is positive, so it goes up. And then it's got to come back down. Now what happens here? Does it keep on going? Or does it go back up? So I'm going to put Positive, let's put positive a half, positive a half. This is going to be negative. It's always negative. A half here, this makes this negative, and make positive a half here makes this one positive. So I have negative times, let me try it again. If I put a half in here, this is negative, darn it. A half here is negative. Two negatives times a positive is positive. This one comes back up. And then we know it has to be going down over here. So it looks like that. Okay? You can't always assume what's going to happen. Now, in a second, we'll talk more about that. Sometimes the curve goes through the point, and sometimes it bounces. Okay? And what is interesting? When you have an x squared, isn't an x squared x times x? So technically, you have four things equal to 0. You get a 0 here, a 0 here, a 1 here, a negative 1.5 here. You got the 0 twice, and it bounced at the 0. You got the 1 once, and it went through. You got the negative 1.5 once, and it went through. We'll come back to that. Come back to that. All right. How about the very last one? X cubed minus 2x squared minus 4x plus 8. We're going to do it by zeros, okay, where the x it crosses the x-axis, the y value is 0. All right, and I said these would factor. Pull out an x squared out of the first term. This is a grouping, and I get x minus 2. Pull out a negative 4, and I'm going to get x minus 2. Now you can pull out the x minus 2, and what do you have left here when you pull an x minus 2 out? Isn't it x squared? And what do you have left here when you pull out the x minus 2? Isn't it a minus 4? And this should jump out at you. X squared minus 4 is difference of two squares, which is x minus 2x plus 2. Now look what happens. We get 2, and we get 2 twice, and we get a negative 2. This goes back to what I just said about the 0 in the last one that we got twice. Okay? So let's sketch it. So here we have negative 2 and positive 2. It's a cubic, positive cubic. Odd degree with leading coefficient positive. It should be down on the left and up on the right. Okay? Now, what else do we know here? When it comes up through to negative 2, so here it's coming up and it's coming up to negative 2, does it keep going up or does it bounce and go down below? Put 0 in. 0, 0, 0 is going to make negative times positive. That's a positive. And 0 in goes the whole way up to 8. So we know it's coming the whole way up to here. Now what happens when we get to positive 2? It has to go back up. We know it's going up on the right, so it has to bend and go back up like that. Okay? Next problem. Okay, so let's try to summarize everything here. Talk about a little bit about multiplicity. The same thing happened here as happened in the last problem, when 0 is used twice. Here we have positive 2 is used twice. Back in that previous problem, when it hit 0, it bounced. Look at this one. When it came down and hit 2, it bounced. Okay? If your zeros are used an even number of times, twice here. Okay, if they're used an even number of times, it's going to bounce. If it's an odd number of times, like the negative 2 is only used once, it'll go through. Now, if you remember this, you don't ever even have to check. You can just look how many times the zeros you're using, it'll tell you how to draw it. Okay? But if you forget, you can always pick a number and check it and see whether it goes through or whether it bounces. So let's try these problems. Okay, this first one, notice this first one is already factored for you. Isn't that nice? And if we're going to graph it using zeros, we're going to set it equal to 0 to see where it hits the x-axis, okay? I know that x times x times x times x times x 4 times. You're going to get 0 from this one 4 times. You're going to get 2 from this one 3 times. You're going to get -1 from this one twice. Yes? Okay, that's how quickly you can do this because it was already factored. So I know I have a 0 at 0. I have a 0 at 2. I have a 0 at -1. Okay? Let's see, what is the end behavior going to be like? You know, is it going to be up, up, down, 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 up, down? Okay? If you were to multiply this all out, your biggest term would be x to the 4th times x to the 3rd times x squared. Wouldn't you agree with me that x to the 4th times x cubed times x squared would be x to the 9th? X to the 9th is an odd power. So we have an odd leading term, and the coefficient is going to be positive. So it should be up on the right, down on the left. Are you with me? Okay? Now, we know it's going to bounce wherever there's an even number of, so here, this was used 4 times. It's going to bounce at 0. This was used 3 times. It'll go through. -1 was used twice. It's going to bounce at -1. So if it's way down here, it's going to have to come up. So here it comes, up to -1. But -1 was used twice, so it has to bounce. 0 was used 4 times. It has to bounce. And then at +2 was used 3 times. It'll go 3 and continue up the way that we thought it should. See how easy that is? Of course, it was already factored. The next one is not factored. So let's do the last one here. X to the 5th minus 16x cubed. I can take out an x cubed. I'm going to be left with x squared when I take 3 out 5 minus 16. This is difference of 2 squares. And don't I get x minus 4 and x plus 4? Okay? All right, here we go. When you solve this, you're going to get 0 3 times. You're going to get 4 once. You're going to get -4 once. So everything here is odd multiplicity. Okay? So I know I have a 0 at 0. I have a 0 at 4. I have a 0 at -4. And now let's check. Oh, here it is. Leading term is an x to the 5th. It's an odd power that is positive. Isn't it down on the left, up on the right? And everything was used an odd number, 3 times, once, and once. There is no bouncing. So if it's down here, it's going to go through everywhere. So it has to come up, down, up. And even more beautiful about this is an odd function. It's symmetrical about the origin, right? Beautiful. Okay, and you can graph it that quickly. So, homework problems, as I said, everything should factor. There's a parabola you can put into standard form, find the increasing, decreasing intervals, max, min, so on, okay? Should be, for the first time in chapter 3, a sign of how easy this chapter really could be.